Hello everyone, this is Mahdi Neser Moqaddasi. I'm a senior data scientist in SiriusXM. This is the final presentation for CS 5331. The project title is Complex Networks and Recommendation System, a Survey. As part of the survey, I'm looking at more than 10 reference published papers in the subject of the recommendation engine, and more specifically its association with the network structures and social networkings. I'm planning to provide different comparisons in the area of the accuracy, performance, and network structures as a part of this survey. I would like to provide these comparisons in such a format that show that what are the available techniques in this regards and how the social networking providing its benefit to the recommendation system. So, as we discussed in the previous presentation in the subject of the recommendation engine, we discussed that recommendation engines is basically a branch of machine learning algorithms and that working in the area of suggesting a service to a set of users based on the available informations and the history data that is gathered in that particular database of companies. If you're looking at the companies like Amazon, Facebook, LinkedIn, and YouTube's, these companies are heavily investing in the areas of the recommendation engines in order to increasing their revenue by selling more products. One of the areas that is very challenging in the recommendation engine is how we can suggesting a service to particular users with the goal that he will basically accept that particular service or getting more interested to buying that particular products. That is why that an area of social networks which is has a link to the recommendation engine would raise among the researchers to more workings in this area with the basics foundations that if a friend of a user is interesting in a particular service, that persons or users might following his friend's advice or recommendations to buying a product. It's very challenging because we don't know initially a great association between the each users. So there is no enough data when a particular systems is established on. But there are techniques that is helping users and the companies to getting to the goal of having such an accurate recommendation engines that we will discuss in this presentation. So in the area of the recommendation engine, one of the topics that is very common among the researcher recently is the social influence. So what is the social influence? Social influence is a change of a behavior that the one person causing another person. For example, consider that you would like to basically buying a new model of the iPhones, but you were talking with your friends and came to know that the recent models is exactly what you want. Or more other example in these areas, you will see that the people are going to particular events, so you get more interested to attending to that particular events. This type of the influence that you seeing basically as a part of the relationship that you have with your friends or your around yourself is called the social influence. But why social influence is an important subject? If you're looking at the new approaches that is basically proposed in the e-commerce website like the Amazon or eBay, it's trying to findings any relationship between the people that who have the similar interests as yours, or more specifically, if you have any particular friends in the social networks, they want to suggesting that do you know that your friend John or Jack, he is also interested to go into these events. Or another example is that in the social networking website like the LinkedIn or Facebooks, you may notice that the website is trying to suggesting new friends based on the mutual friend that you have. So since you already know your friends, you'll be more interested to following his interests, or you will get more trust in the behaviors of what he has already done. So that is why that the researcher or the companies that who are actively working in this area try to using this social influence as a trust factors to providing a service that is customized to your behaviors. How do you will accessing this social influence? One way is to basically having a networks, social networks of the people that who are friend with you or that or connecting to you, and finding that friends that who are more closing in the definition of the set of the attributes that more specific to that company, and seeing that what that particular friend has done that will be close to your interests as well. This is the missing puzzle of the traditional recommendation engines, that they will not consider in this network structures or network-based social recommendation engines into the factors. So we will talking about more about this in the following slides. So we were discussing that the traditional recommendation engine that we were working on it doesn't have the concept of the social influence in their models. By the time that the researcher find out that how they can relate it, this concept of the social network to the recommendation engines, the research in this basically area started. One of the earlier research is by the Cohen, Harish, and Basu, that they proposed the first social network-based recommendation, which is basically a mixture between the content-based information that we have and mix it with the social networks. And they were discussing about basically the new approaches and the pros and the cons of the systems. So in the area of the social networking and the recommendations, obviously there are different researchers, but one of the areas that that has been discussed is the social tagging. Social tagging is basically tagging information that the user providing for a product. For example, if you're looking at the Amazon, you might notice that some users, for example, if they're reading a book or a product, they will, with a very short term, they will explain that their experience with that particular product. They can say that this book is a mystery, or it was a quick read, or so on. Whether it can basically in the support, or it can have basically the negative experience that they have. So using this tagging informations was one of the approach that's basically helping to improve the social network and to make it more powerful and useful. There are two techniques that has been discussed. One is the random walk through the social tagging informations, and based on that extracting the communities and finding the relationship between the users. And another one is among one of the papers that has been discussed is the ForkRank. ForkRank is coming as an extension of the PageRank algorithms that is running over the set of the taxonomy, and taxonomy is nothing but another term for the social tagging. So basically the users are using the concept of the page rank algorithms, which we're discussing in this course, to finding out that who is basically suggesting a product and how important that particular person would be, and using this Fortran algorithms to suggesting a service or particular recommendations. So now the question is that, are we done? Does it mean that if we are combining the social network with the recommendations, does it meaning that it's answered all questions? So obviously not, and here we are discussing about the three problems that has been raised. So sparsity is a problem that you don't have the enough information about the particular products. So simply, if you don't have the enough informations, you will facing the sparsity problems, as well as the other problems that I will discuss. So the researchers have now to basically findings or combining the different techniques to maximize the power of the recommendation engine with the social networking. Other problem or challenges that we have seen in this area is over specializations. Consider that your friend doesn't buy any product or a particular service he has not been used, so he cannot suggest it to you. So how we can overcoming the problem that we don't have specific data for a particular product? This is called over specializations. Other than that, there is another problem called limited content analysis. Consider that for the recommendation engines that we have, somehow we wanted to extracting the future of the products. But what if the product that we have is something like a graphic image, or let's say that you want to suggesting a particular image to users. So you need to somehow finding some metadata information to analyze that particular objects and finding the relationship between the set of users based on those attributes that you extracted. So that is why that you wanted to adding or injecting this metadata information to describing that particular objects, that we call it as the content analysis. So if there is a lack of the information on this engine or models, that will be also challenging to having an accurate recommendation engine. So when we are planning to evaluating a particular recommendation engine, we are looking at the output of the basically the recommendations on a set of the data that we are passing to the system. So how this output will basically generated? There are two common phases mostly among the recommendation algorithms to basically generating a set of outcome for particular users that we have. Those phases are filtering and the ordering. Filtering is when you are separating the particular node that is most likely would be recommended to a user. So you know that a particular friend or particular item is going to be represented based on the threshold that you define in your systems. So you will put that particular node in a list, and you're separating it from the other nodes which will not be a potential candidate. Ordering is that once you have this list, you will go through it and rank it, or basically sort it based on that what particular items would be first recommended to the users, and having this ordering will be providing the more accuracy. Consider that you have the several product of let's say that the tablet for particular users. You will ranking this set of the set of the items that you have and present it to the users based on the ranking that you have. So now you have these informations or the outcome available. How you want to evaluate it? Unlike some other machine learning approach that you can dividing the set of the data to the testing and the trainings, here in the recommendation engine it will not be as easy as such, because you want to having a feedback from the users to know that, okay, if I am basically presenting a particular item to the users, whether he will be interested or he's basically just decline it. So this way of the getting the feedback would not be something that would be very easy to implement unless that you're providing some level of the survey or embedded the code for getting this particular feedback in your applications. For example, Amazon can potentially having a way to see that if he's suggesting an item to the user, what will be the behavior of the user to that particular action, whether he's accepting it, doesn't do anything, or just decline that offer. So this feedback will be help to in basically retune the recommendation engine and making available information to see that how accurate the system was. So there are two levels of the measurement that going hand by hand when you want to doing the analysis of how well your recommendation engines perform after getting this feedback. One is the accuracy and the other one is the coverage. Coverage is when you want to see that what percentage of the items that you have in your basically products or in your warehouse or in your database, what fraction of those has been recommended to the users. Let's say that you have different set of the tablet and you have the social networking system that basically using this recommendation engine to offering the tablets from the list that you have. You want to say that are you suggesting all options that you have, all the items that you have, or is that like always different specific brands or suggesting to the users? That will be coverage. The more it will be, obviously the better your recommendation engine is performing. And the other one is the accuracy, which is basically another way of the measuring the performance of the recommendation engines. And there are some common factors and measurements like absolute mean square, precision, and recall, and other metrics basically to helping evaluation of the recommendation engine. It is important to note that the accuracy and the coverage are going hand by hand, meaning that if you have the high coverage but not that much good accuracy, it doesn't mean that your recommendation engine are working well, because it may also mean infer from the recommendation engine that it is without any intelligence, it's just representing all the items that it has to the user without considering whether it's relevant or irrelevant. So that is one of the aspects that is important. Other than that, in the social networking recommendation engines, it is also implies that once you can providing a level of the trust between the nodes that you have. Nodes can be users or friends. The chance that you're increasing the accuracy will be going high. For example, there is a website called Film Trust, which is a web-based social network website that is offering basically movies to the users. The way that it works is that for each particular user, looking at its friends and based on what the friends are already watching, they're suggesting those items to the particular users. The reason for that it's claiming that its accuracy is more than other algorithms in the same domain is based on the factors that the humans or friends are very much likely to do the same thing in some areas as their friends are doing. So working in such a way that providing this level of the trust between each node, that if your friend is following this particular product, there is a most likely that you will also get more interested to buying or following that patterns, will increasing the accuracy of the recommendation engines. In the next slide, we are planning to going for a conclusion and the discussions that though the social networking website are showing that it has providing more accuracy and the coverage and surpassing the other traditional recommendation and engine that we have, what are the other challenges that we are seeing, and basically making a conclusion on that. So in this paper, we were discussing about the influence networks and social influence and its application on the traditional recommender system, which will be lead to providing the accuracy and more coverage for the particular algorithms. There are some implementations that of the social networking, like in a graph base and other approaches that will basically using the social networks and the trust level behavior between the different nodes to recommend a particular service. But mostly they are based on the simple fact of that if you are friends and if you have and the behavior of your friends will be impacted on the decision that you wanted to make, which is a social influence. One of the things that one of the challenges that have not been discussed fully is that the privacy issue that we are seeing once we want to implement a social network based recommendation system. For example, Facebook has one of the greatest huge number of nodes in their database by representing each user as a node, but mostly this data are available for that particular application, which is a Facebook. Having access into the set of this set of the informations, we may face some the privacy issue to the what level we would like to extract in these informations. So that is one of the challenges that we are seeing in this basically social based networks that may overcome in the futures. So as a part of this survey, we look at a set of web-based and other social-based networks, and we were discussing that by using the social networks and adding this value information to the traditional recommender systems, we have achieved a better accuracies. And we were discussing the challenges that we have seen in this area, either irrespective of the hardware challenges which can be implemented through the cloud infrastructures, and other challenges like privacy and other specializations and data sparsity and so on. We also discussed that by implementing social-based networks in such a way that showing that each particular users or a friend having a trust relationship to the other nodes, we can increasing the performance. That is one of the application of social networking, which has been discussed in a website called Film Trust. By saying that this was a brief overview of the available some of the available research that have been done in this area. Obviously, this is not covering the old paper in this literature, but I'm hoping that is providing a ground for the future research. I would like at the end to thank you, all of you, for seeing this presentation. If you have any question regarding this presentation, and if you would like to know more about it, please do not hesitate to contact me. My email address is madi.muqaddasi@ttu.edu. Thank you very much.